Okay, so here's B-4. And good news, guys, my nice new camera came in, I guess. Or no, it's shipped. It is shipped, so the quality of our videos is about to get a lot better. But I'm going to do two examples in this video. So example one, find a value of a so that the function below is continuous. So this is a piecewise function. And this part down here involves this constant a, which we're trying to find. All right, so we want this function to be continuous. And when you're doing a problem like this, guys, where you've got a piecewise function and you're just looking for some missing constants that would make the function continuous, what you really want to focus on is the second condition of continuity, which is that the limit exists. So, yeah, because it's this condition of continuity that's going to let us, like, put these pieces together, so to speak. All right, now, so this is what we do. We do the left-hand limit and the right-hand limit at this end point. So what's happening, guys, is we've got this, all right, so there's 3. And this is like, the end point of the two intervals that this function is defined on. So for x is less than 3, so on this part we've got x squared minus 1, on this part 2ax. All right, so what you do is you've got to make the left hand and the right hand limits match as they're approaching this number 3, the end point of the intervals. So I go the limit as x approaches 3 from the left of f of x. All right. And if I'm, okay, so this limit, guys, this is the limit as x approaches 3 from the left. So if our x values are to the left of 3, then f of x is defined as x squared minus 1. Okay. And now I'm just going to think. So I want to think of numbers like 2.9, 2.99, 2.999. So about 3 squared is about 9. And about 9 minus 1 is about 8. And as we get closer and closer to 3 from the left, x squared minus 1 gets closer and closer to 8. So the limit is 8. All right. Now we'll do the limit as x approaches 3 from the right of f of x. And guys, when I say in the directions to use like careful or precise notation, this is what I'm talking about. See how I'm just like writing this out so carefully. So that's what I mean when I say precise notation. Like the limit is where it's supposed to be. What's in the parentheses is clear. Okay, so this is the limit as x approaches 3 from the right. Okay, because for x values to the right of 3, f of x is defined using that piece. Okay, now, so x is getting closer and closer and closer to 3, but we're to the right, so like 3.0001. So 2 times a times about 3. 2 times a times about 3. Well, 2 times a times 3 is 6a. So 2 times a times about 3 is about 6a. And as we get closer and closer to 3 from the right, we are getting, this expression is getting closer and closer to 6a. So that's what the limit is, 6a. All right, now guys, here's the thing. The second condition, we want this function to be continuous, and the second condition of continuity says that the limit has to exist, which means that this left and right hand limit have to equal each other. So what you want to say now is that 6a Okay, so I'll be like, for continuity, we need 6a to equal 8. All right, so a is 8 over 6. So a is 4/3. Okay, now I'm going to do another one. So that was an example where you have one endpoint. Now we're going to have two endpoints. All right, so same directions as example 1, but we're finding a and b. So this piece is x plus a, this piece here, this piece bx plus 1. So let me do like a little number line. All right, so there's 4, there's 9. All right, for all these numbers, f of x is x plus a. Here it's x minus 1 squared. Here it's bx plus 1. You don't have to do this part, guys. This is just for me explaining. I wanted to put something there. And maybe I'll go like this too, because we gotta approach these endpoints from the left and right with limits. So 3.999, 4.0001, 8.999, 9.0001. Okay. Alrighty. So I've got to do the limit as x approaches 4 from the left and from the right. All right, so let me do that now. The limit as x approaches 4 from the left. Now, just to save myself some writing, like before I was putting f of x in, and then in the next part I was putting the piece of the function that f of x was on that interval, but this time I'll just jump right to that part. So if I'm to the left of 4, it's x plus a. Okay, guys, so about 4 plus a is about 4 plus a. Okay, and as we get closer to 4, we get closer to, this gets closer to 4 plus a, so 4 plus a. All right, now the limit as x approaches 4 from the right. Okay, if we're to the right of 4, we're using this part there. All right, so this is about 4 minus 1, which is about 3. About 3 squared is about 9, and we keep getting closer to 9 as x gets closer to 4, so that's the limit. All right, and then I guess I'll go like this. For continuity, we need 4 plus a to equal 9. Okay, so we need 4 plus a to equal 9. So we've got a equal to 5. Well, that wasn't too bad. Alrighty, now let's use this endpoint. So we got to approach 9 from the left and from the right and do the limit. So the limit as x approaches 9 from the left. All right, we're going to use that piece. So about 9 minus 1 is about 8. About 8 squared is about 64, and we keep getting closer. So that's the limit. Okay, so b times about 9. B times about 9 is about 9b. So this whole thing is about 9b plus 1, and we keep getting closer to it. So that's the limit. Okay, so, all right, so for continuity, we want 9b plus 1 to equal 64. So 9b to equal 63. So b to equal 7. All right, guys, so there it is. Oh, I just made it under 10 minutes.